Hello, my name is Ryan Regalado, and this is my CAI application for the spring of 2025. And so for our first example, we have a explanation of the difference between confounding variables and causal links. So my little diagram here, we have an experiment with an independent variable and a dependent variable. And this arrow represents a causal link, where this causes this. So the result of this experiment, this mock experiment here with arbitrary um, variables here, means that this independent variable causes this dependent variable. And that's what basically this diagram is showing. And on the contrary, we have something called a confounding variable, where the relationship isn't so clear anymore. We have a third player here that lives up here, and he influences the independent variable and influences the dependent variable. And so the main difference is that a causal link explains the cause between the two variables. So it would explain why this causes this. And the confounding variable is basically something that obscures, I guess, messes with the relationship between the two, so it's not so clear cut and obvious. And so this is best explained with examples. So I'll bring back the page yet again. And we have here pro athletes and regular Joes in this experiment of sleep per day. And so we see that the pro athletes in my made up examples get 6 hours of sleep a day, and in here the regular Joes get the 8 hours of sleep a day. So a causal link would say that because you're a pro athlete, you sleep 6 hours a day, you'll sleep less than regular people because you're a pro athlete. And what this experiment is missing is a confounding variable that is hidden, and sometimes these are tricky to find, but it's hidden because it has to do with travel. So we have travel here as a confounding variable because when you're a pro athlete, you travel, so travel affects pro athletes, and when you travel, you sleep less, more or less. Yeah, you sleep less. So that's the confounding variable. The pro athletes don't necessarily sleep less than people, and there's a causal link between that. It's because there's travel involved. As a pro athlete, you sleep less. And so this traveling confounding variable distorts this relationship. It makes it a little more complicated than it would be if it was direct causal link. That's my explanation of causal links versus confounding variables. That's displayed with a diagram, and that's how I would teach it if I were in class. And the next topic is filtering a data set to get, I think, is freshman level classes, a random sample of freshman level classes. Yes, that's what it is. So our mock student, my left, imports pandas as PD. Congratulations. That is a great first step as PD. So I'm just going to write this down so it's visible. They read in the data set. Read underscore CSV blank, or the GPA data set, whatever that is. And then, so this is what I have so far, or sorry, what they have so far. This is their work. And they approached me with a question, and they're stuck. They're wondering, Ryan, how do I even determine what is a freshman level class? To that, I say you need a helpful piece of information that 100 level classes, anything that starts with 1 in the course number, are freshman level classes. And without that step, it's kind of hard to do this problem. That's kind of the jump you have to make. So they think about it for a minute and they're like, hmm, okay, so if I use a conditional where I have df.numbered is less than 200, right? Not including 200, but less than 200, and that works. And I'm like, yes, you're on the right track, but in order to ensure this is the right, you know, interval, I guess, of class numbers, you need a bottom bound. So that requires a complex conditional. And so a complex conditional mock student uses two conditional statements and joins them with and or or. So you have to think about your relationship here between your desired interval and your conditional statements. So you want everything from 100 to 199. So how are you going to section off this range of classes in order to do so? And with this question, it prompts the student to think, okay, so I need everything that's above 99 and below 200. And so that is correct. The student gets there. And they write the code. 200. So they're typing it away right now. I'm just writing it all out for the sake of this. So they have their new df here, right, with this little complex conditional, and congratulations, that is the correct filtered data frame. Now, another student comes up to me, mock student 2. She goes, Ryan, I am so stuck. I do not know how to sample 10 people. I'm using for loops. I'm using blah, blah, blah. And I simply respond, have you looked in the back of your discovery notebook? So she does, and she finds a helpful function, df.sample. df.sample with an argument, which is, yes, correct. That is the number of items in your sample. So the number would be 10. So with our filtered data frame, we're going to do df.sample parentheses 10. Now that should give us a sample of 10 classes, 10 freshman level courses. This is Ryan Regalado. Thank you for listening to my interview, to my kind of mock explanation here with my fake examples and fake students. So thank you for listening and thank you for your time.